Hello everyone! Pag-usapan natin ng limits at infinity. Without further ado, let's get this lesson started. Pag sinabi nating limits at infinity, ang condition dito ay yung function na f of x, yung x doon or yung input doon ay palaki ng palaki, increases without bound. Habang ganun yung behavior ng x values, yung mismong y or yung mismong f of x palapit ng palapit sa isang value L. Or yung limit ng f of x as x approaches a very big number which is represented by positive infinity is equal to L. Kumbaga, palaki ng palaki yung value ng x as represented by positive infinity. Tapos, kapag ganun yung behavior, yung f of x palapit ng palapit sa L. Yung kaibahan nito sa previous video natin na infinite limits, ito kasi, yung infinity, hindi yun yung sagot. Infinity, yun yung value na nilalapitan ng x natin. Or ito yung ina-approachan ng x value natin dun sa f of x. So, ito yung una nating definition. Limit of f of x as x approaches positive infinity is equal to L. Let's have the first example. Sabihin natin meron tayong rational function na 2x squared over x squared plus 1. Tingnan natin kung ano yung magiging behavior ng f of x kung meron tayo ditong x na palaki ng palaki ng palaki yung value. Ito yung mga pinili nating value kasi based on the definition natin sa previous slide, yung x daw approaches positive infinity. And positive infinity means a very big number. So, isolve natin dito yung kanyang value. Meron tayong f of x. I-substitute natin. We have 2 times 1 squared. Then we have 1 squared plus 1. Obviously, the numerator will be 2. The denominator will also be 2. So, the answer here is 1. Next, for f of 10, oh, by the way, this should be 1, f of 1. Kasi 1 yung sinubstitute natin. We have here 2 raised to 10 squared all over 10 squared plus 1. So, 10 squared is 100 times 2 is 200. All over, this is 100 plus 1. So, 200 divided by 101, let's use our calculator. So, we have 200 divided by 101. I-round off natin sa second decimal number, we have 1.98. And let's do the same for 100. This is 2 times 100 squared all over 100 squared plus 1. 100 squared is 10,000 times 2. We have 20,000. And then this is 10,000 plus 1. So this is 20,000 all over 10,001. Let's use again our calculator. We have 20,000 divided by 10,000. 1. This time, let's round off to the fourth decimal number. We have 1.9998. 1.9998. As for the other values, I leave it for you to show the solution, pero ito yung kanyang magiging values. As you may notice, as x approaches positive infinity, yung f of x natin palapit ng palapit sa value na 2. Kung makikita natin yung behavior ng f of x, paliit ng paliit yung kanyang distance sa 2. That is why if we are going to write its limit notation, we have limit of the given function 2x squared all over x squared plus 1. As x approaches positive infinity is 2. Doon naman tayo sa second definition, na ang involved naman dito ay yung x ay nagde-decrease without bound. Kung kanina ay increase, dito sa second definition natin, decrease naman. Ang pinagkaiba lang niya, yung ina-approach na value ng x ay negative infinity. In other words, as x becomes smaller and smaller, yung f of x becomes closer and closer to its limit L. Let's have another example. Let's use this f of x and this table of values to identify the limit as x approaches negative infinity. Negative infinity yung ina-approach ni x kasi kung makikita ninyo sa ating values, lahat yan ay mga negative numbers na palaki ng palaki yung value. So, una, meron tayong f of negative 1. f of negative 1, this is 3 times negative 1 minus 6 all over 4 minus negative 1. This will be negative 3 minus 6 over 4 plus 1. This will be negative 9 over 5. So dividing them, we have negative 9 over 5. This is negative 1.8. Next, meron naman tayong f of negative 10. Dito, meron tayong 3 times negative 10 minus 6 all over 4 minus negative 10. So, for the numerator, 3 times negative 10 is negative 30 minus 6 is negative 36. 4 minus negative 10, magiging plus ito, plus positive 10, so we have 14. Let's use our calculators to divide them. We have 36 na negative. I-divide natin sa 14. The answer is negative 2.57. Let's just use the second decimal number. Negative 2.57. So, ito, negative 1.8, negative 2.57. How about for negative 100? Meron tayong 3 times negative 100 minus 6. This is 4 minus negative 100. 3 times negative 100 is negative 300 minus 6. This is 4 plus 100. The numerator, ito ay magiging negative 306 all over 104. So, meron tayong 306 na negative. I-divide daw natin sa 104. The answer is, let's use the fourth until the fourth decimal number, negative 2.9423. Negative 2.9423. For the last two values, I leave it for you to fill out, pero ito yung kanyang correct values. Kung makikita natin yung x, paliit ng paliit yung kanyang value as it approaches negative infinity. At the same time, yung f of x naman palapit ng palapit sa isang number and that number is negative 3. That is why, when we get its limit, the limit of f of x as x approaches negative infinity, we will get negative 3. Pero hindi naman palagi na kailangan nating gamitin ang table of values na ito. Siyempre, meron tayong option to use the algebraic method or yung mga limit theorems para makuha yung limit ng isang function as it approaches positive or negative infinity. Kaya pag-usapan natin yung theorems on limits at infinity. Sabihin natin meron tayong r na kahit anong positive integer. Kapag ganito yung format niya, naka-fraction, na ang numerator ay 1, ang denominator ay x raised to r, tapos, ang limit ay approaches positive infinity. So, ang answer natin sa limit ay 0. Same goes if x approaches negative infinity. So, ito yung dalawang theorems na kailangan nating tandaan para ma-evaluate natin yung limits at infinity. Again, paano malaman kung limits at infinity yung involve? Titingnan natin yung x. Dapat yung x approaches positive infinity or negative infinity. Para masabi natin na applicable itong theorem na ito. Let's have the third example. Sa unang tingin, mukhang pwedeng gamitan ng theorems on limits at infinity dahil naka-fraction siya. So, subukan nating gamitan ng iba pang theorem bago itong nasa left side ng slide. So, since naka-subtraction sila, we can use the difference rule. Meron tayong limit of 4 over x to the 6 as x approaches negative infinity. minus the limit of 1 over x cubed as x approaches negative infinity. Ito, wala na tayong problema dito dahil nag-conform na siya sa pinaka-pattern. Dito tayo sa una may problem kasi may 4 pa. So, pwede natin gamitin yung constant multiple rule, ilabas natin si 4. Maiwan na lang yung limit of 1 over x to the 6 as x approaches negative infinity. Ito, pwede na nating direct na gamitan ng theorem. Ito ay automatic 0. Bakit 0? Kasi according to this theorem, kapag daw naka-fraction at ang denominator natin ay x cubed or x raised to any power of r, automatic siyang 0. Same applies with the limit inside this parenthesis that is just equal to 0. So this is 0 minus 0 or simply the answer to example number 3 is 0. Sa part na to, actually, pwedeng ilagay agad natin na ganito yung maging answer dahil kahit ano namang number ang ilabas natin, yung maiiwan naman na limit ay laging magre-result sa 0. So, i-apply natin yon sa mga susunod pang example. Yan. So, ito naman, hindi natin pwede agad gamitin yung sum and difference rule or yung quotient rule dahil wala pa yung format na nandoon sa Theorems on limits at infinity. Wala pa ito, itong 1 over x to the r. Kailangan niyang lumabas. So, ang gagawin natin, palalabasin natin yan, imumultiply natin yung buong function sa 1 over x all over 1 over x. Doing that, we still have here the limit notation as x approaches positive infinity. Yung 5 magiging 5 over x. Yung x magiging x over x. The denominator, 2x over x minus 11 over x. Kumbaga, parang nilagyan lang natin ng over x lahat ng terms. Over x dahil yun yung highest exponent sa numerator at denominator. So, meron tayong limit of x approaches positive infinity. 5 over x will just be 5 over x. X over x will just be 1. Ito, matatanggal na si x, madidivide na, 2 na lang yung maiiwan. Minus 11 over x. In that way, may makikita tayong dalawang fraction na nagko-conform dun sa pattern ng theorems on limits at infinity. I-distribute ngayon natin yung limit. So, we have here the limit of 5 over x as x approaches positive infinity. Plus, the limit of 1 as x approaches positive infinity. All over the limit of 2 as x approaches positive infinity minus the limit of 11 over x as x approaches positive infinity. So, yung mga may fraction na ang denominator ay x, we know, according to the theorem, na yan ay 0 na lang. Ito din ay magsi-0 na lang. So, ang result natin ngayon, 0 plus 1. Recall that the limit of a constant, kung ano yung constant natin, kahit ano man yung ina-approach na value ni x, yung constant yung sagot sa limit. All over, ito din, 2 minus 0. Simplifying, we have 1/2. So, ito yung kanyang limit as x approaches positive infinity. For the fifth example naman, meron tayong 9x squared plus x minus 10 all over 3x squared minus 8x, and we will get its limit as x approaches negative infinity. Tulad nung ginawa natin kanina sa example 4, kailangan may maging result na naka-fraction, kaya ang imumultiply natin dito ay 1 over the highest exponent among all the terms, which is x squared. 1 over x squared. Kung meron ditong x cubed, tapos sa denominator x squared, lagi dapat masusunod yung highest exponent. So, dito ay x squared yung involved. So, still we get the limit as x approaches negative infinity. This is 9x squared over x squared plus x over x squared minus 10 over x squared. For the denominator, we have 3x squared over x squared minus 8x over x squared. Simplify natin yung mga terms nandoon sa function natin. 9x squared over x squared is just 9. Matatanggal na si x squared. Ito naman, by the loss of exponents, mababawasan ng exponent yung nasa denominator. So, this will just be 1 over x. And then this is 10 over x squared. For the denominator naman, matatanggal na si x squared, 3 na lang. And then, matatanggal na yung x dito sa 8. Tapos, ang kanyang denominator ay x na lang. After simplifying, pwede na nating i-distribute ulit yung mga limits. So, we have the limit of 9 as it approaches negative infinity plus the limit of 1 over x as x approaches negative infinity minus the limit of 10 over x squared as x approaches negative infinity. All over the limit of 3 as x approaches negative infinity minus the limit of 8 over x as x approaches negative infinity. Yung mga constant, like this first term, we know the answer there is 9. Tapos ito, kapag naka-fraction at may denominator na x or kung ano mang x squared, x cubed, ito ay automatic na 0 according to the theorem, as well as this third term in the numerator, dahil naka-fraction siya, this is minus 0. For the denominator, we have here a constant, limit of a constant 3, minus 0. So the result will be 9 over 3, na kapag ni-lowest term or dinivide, the answer is 3. So, ito yung limit ng ating f of x for example number 5. Let us have this example number 6. Meron tayo ditong f of x na among all the terms, ang highest natin ay x cubed. Yun ay makikita sa denominator, pero sa numerator, wala tayong x cubed. So, tingnan natin kung ano ang mangyayari kapag sinunod natin yung pagmumultiply ng 1 over the x raised to the highest exponent, which is 3. Tatandaan, ang pagmultiply dito ay yung laging highest exponent. So we have still the limit notation. This will be x squared over x cubed minus 12 over x cubed. Ganon din yung mangyayari sa denominator. Lahat ng terms ay malalagyan ng denominator na x cubed. Tapos, isi-simplify natin yung mga terms bago natin kuhanan ng tig-isang limit. The first term in the numerator, by the loss of exponents, this will just be 1 over x minus 12 over x cubed. As for the denominator, same sila. So, this is just 1. Tapos, gamitan ulit ng loss of exponent dito. We have 5 over x. And dito, we have 1 over x cubed. Kuhanin natin yung limit ng bawat isa. Yung 1 over x, dahil ito ay naka-fraction na, we know for a fact that that will result to 0. Pag kinuhanan ng limit, as well as for the negative or minus 12 over x cubed, its limit is also 0. For the denominator, we have 1 plus, another 0 ito, plus 0. Simplifying the numbers here, the numerator will be 0 over 1, at alam naman natin na kapag may ganito tayong fraction, na 0 ang numerator, the answer is 0. So, ito yung limit ng example number 6. Let's have the last example, number 7. Dito ang leading term natin ay x squared, kaya kuhanin natin yung reciprocal niya at i-multiply natin both sa numerator at sa denominator. Tingnan natin kung ano yung mangyayari dito sa example number 7. So, we know this is still x squared over x squared plus 11x over x squared minus 7 over x squared. As for the denominator, ganun din. Both of them will have a denominator of x squared. Simplify muna natin para mas maging klaro yung bawat terms. So this will just be 1. And then, ito na second term ay magiging 11 over x na lang minus 7 over x squared. As for the denominator, meron na lang tayong 1 over x minus 16 over x squared. Again, sinimplify natin siya using the laws of exponents. Pwede na natin kuhanan directly ng mga limits. So, sa numerator, ang limit ng constant 1 is just 1. Itong 11 over x ay 0. Negative 7 over x squared is also 0. As for the denominator, ang limit ng 1 over x, dahil naka-fraction siya, is still 0. At itong negative 16 over x squared, that is also 0. So, lumalabas na ang answer natin ay 1 over 0. Which is undefined. At kapag undefined, ang kukuhanin natin ay yung ina-approach na value ng x. Ito. Always remember that if your answer leads to an undefined, tapos theorems on limits at infinity yung involve, or ito yung ina-approachan ng value ng x, ito yung ating magiging answer din. So the answer, for example, number 7 is not undefined. Instead, it is negative infinity. Kukuhanin natin yung x value na ina-approachan, or in this case, that is negative infinity. So, ganyan tayo gumamit ng theorems on limits at infinity. Tatandaan lang natin na kailangan mag-result sa isang fraction na ang denominator ay x raised to a certain integer. Para ma-applyan natin ang theorem at ang limit ng ganong term is just 0.